welcome everyone. Thank you very much for coming and assisting to this presentation. I must admit, I was a bit afraid actually having so many people today, but when I see the massive room this morning, I'm feeling more confident. I wouldn't want to be on that stage. Let me set the expectation for this session, because I have no idea what exactly you're going to come and seek for. I'm going to talk about a chaos engineering working group for the CNCF. Now, maybe some of you will, have come here to actually understand how to use chaos engineering. I don't think that would be exactly the right session for that. So I'd rather set the expectation. I'm going to discuss basically roughly the idea of chaos engineering, and then why we need a working group, why I believe we need a working group on that. But because the idea of a working group is to collaborate and all federate around the idea, you'll be more than welcome to participate to that discussion after that. So I really hope that you'll get what you wanted to get from this session. Right, if that works. Let's have a clue. No? Come on. See, defeated first slide. That's chaos engineering for you. That's fine. I'll do with... All right. I'll have Haiku for you on chaos engineering. So I don't know if you're aware of Haiku. Those are just short sentences that try to reach you, bring you large stories in few words. So we love our systems. Yeah, thank you. Yeah, that works. Thank you very much. But they tend to fail all the time. Now, funnily, I'm sure some of you think that's not true. Your system never fail. Well, they actually do, or the system underneath do fail. But we tend to turn a blind eye. As developer, we're not really taught to actually think about failures. We're taught to build things, deploy them, and then move on to the next feature. But that thing that we've put in production doesn't stop there. It will fail. It will break in some fashion, purely because either you have a bug, fails on its own, or the thing underneath will break, or your users will break it. But we tend to think that it's a bug. I don't want to deal with that bug. I found that extremely interesting to actually look at why it failed and actually learn from that. So I'm going to start with a story, because you had lunch, you may be bored with what I'm saying already, so I'll try to catch up with a story. That's a story of the man and his phone, based on true events, right? So no shenanigans with CSI here, it's just a script, really scenario, Matt Damon style. A man takes security seriously. He has set up 2FA on all his accounts. Who's using 2FA for their Gmail or things like that here? Right, pretty much everyone, or at least a large group of you. He's using Google Authenticator. Now, who's using that one to actually get the code? Less so, but already a good portion. That's a serious story now. A lesson learned. That's the first stage of our story. The phone dies. So what happens if Google Authenticator is on the phone that has just died? How do you get the codes? Well, faulty battery, by the way, you probably never predicted that, did you? Oops, the man says, because it's for all audience. I said oops, but usually those words are way different. I can't produce the 2FA codes anymore. And obviously, because I'm an engineer and I know better, I didn't print the codes, did I? Who's printing the codes that they give you when you set up the 2FA and put them aside? Well, some of you. Bravo. Bravo. So a lesson is learned, one that you shall never forget. Don't bet on a single device for your 2FA. At least don't mix the two. Where you come, you bring your codes from and where you're using them. Shocking events occur. New phone gets stolen. The guy, the man has, no luck perhaps, but that's a story we have in here. The man says, I'm using my laptop to generate codes. I'm not using the authenticator anymore, the Google one. I learned my lesson. Problem is, the phone was stolen in a foreign country and the laptop is nowhere to be seen. So I can't access the codes. Well, the man can't access the code. Oh, again, you'd get the gist, probably different words. Worst part, the phone was stolen, So if the thief gets into the phone, all emails, everything is actually freely accessible because it's already authenticated. So now you can't actually exclude the person from using your phone, and you can't generate another code because, well, you don't have your laptop, you're in a different country. And again, the man knew better, but didn't do it because, he's an engineer or some sort. So he's still, in bad luck. A new lesson is learned: print stupid codes. But then again, to be continued, because if you get the code on paper, do you bring them? I mean, it gets a bit crazy that way. Now, what's the point of that sophisticated story? That everything, surprises come. You know that, right? And if you get familiar with with those surprises or unexpected events, that will save your bacon. So basically, what I'm saying here is, for that story, what you would want to do now is tomorrow ask yourself, what if my phone is stolen or dies? Can I still access my different accounts? What happens to me as a user? Well, that's exactly what you would want as a chaos engineer to think of your system. What happens if this happens? That thing that you probably don't think it would ever happen actually does happen. So that's the mindset as a chaos engineer you probably want to have. What happens if? For the credits, I am the man, so it happens to me. My phone died. 6 months later, it got stolen, and I still don't know what to do now with the print with the code. Perhaps 2 phones, I don't know. All right, let's get started now, because that story was fun, I guess. But this is what we are for. We're going to start with the principle of chaos. Who is familiar with those principles? Actually, come back to that. Who's familiar with chaos engineering in general? Right. Who's practicing a variation of chaos engineering, like resiliency testing? Some people already. So good. Because like I was saying, some of you are coming for new knowledge entirely. Some of you already know quite a bit. So I'm trying to find the right balance here. But let's start on the principle of chaos. Who has read them or gone through the page, perhaps? Right, a few of you. It's just one manifest, really. It's quick to read. It's interesting to see where it comes from. So you should really look for it and just read the page. But basically, the first sentence is this one. It's a discipline of experimenting on distributed system to build confidence when bad things happen. And they will happen. So it's really a when, not an if. Now, the question here, again, we are about to talk about a potential for working group at the CNCF. So that definition, as good as it is, will be discussed by the community. Maybe we'll drop the distributed, because do you need distributed system to actually do chaos engineering? Do you need Kubernetes to actually qualify to do chaos engineering? Probably not. It happens if you have a production system, basically. If you have a production system, you probably benefit from that. Now, that's a quote I took from, I know once you get the slide, go to that URL. That PDF is very short. It's 2 pages PDF to read. It's a very interesting one, about 20 years ago or something. And it's all the cases for failure. It's really interesting to read. But the one that really struck me was, the more you get familiar with hazard and basically danger in your system, the better you get at fixing or handling that. Who's been on call sometime and thinking, God, please don't let the system break down, because I have no clue. A few of you, right? I've been there, where you're like, oh, come on. Because really you haven't practiced. Your colleague is an expert on that. He's always save your ass, or sorry for well, you know what I mean. So I get carried away. But he's not here today. Maybe he's on holiday. Maybe it's just it's your turn to be on call, or whatever. But you haven't practiced. He may have given you a wiki. Maybe I've given you a lot of things, but you haven't practiced, so you're not familiar with the problem. So you're going to get slow, stressed, and stress under failure is not good. It's not the position you want to be in. So practice beforehand with chaos engineering, so that when what happens, maybe a slightly different scenario, at least you feel confident you can do it. You know maybe the venues, who to talk to, and things like that. So the more you practice failure, the better you get at them. So some context. Netflix is the origin for that. Now, system failure or system theory is not invented by Netflix, but they coined the chaos engineering term, and they've done a lot of things in our industry in general. Microservices and plenty of those things seem to be born there. So usually we try to pay attention. In about 10 years ago, I started to explore about the ideas of failure in the system. So at first it was just inside their system. Then they released Chaos Monkey, which was certainly some of like an outcome of that from the system, from the exploration. Who's using Chaos Monkey maybe, or who's just tried? All right. Okay, good. Then they started to organize themselves around the role of chaos engineering by hiring properly chaos engineers. And now they are on well, not Netflix per se, but people from that era are educating with the principle of chaos or the chaos engineering short book that you can find for free on O'Reilly. And so what's next, basically? Because Netflix seems to have done, over 10 years, covered all the ground. Well, it's our turn now. It's a whole world. That diagram is actually not up to date. And don't try to read it, it's way too small. But the idea here is to just show the sheer number of people and variety of people already either doing it or creating tools around it or talking about it. So it's really become a whole ecosystem around chaos engineering. Even if it's quite new, it's fast, on the speed lane. I think the chaos engineering Slack is about 800 people right now. So there are quite a few people interested in the subject. So why chaos engineering? Cost of ignoring weaknesses existence, not ignoring weaknesses, but ignoring that they exist. That's different here. You may know that a weakness exists, but you've made the choice to ignore it. That's fine. You may think that from a business perspective, fixing it is not actually that important, and that's okay. But ignoring that you don't know about weaknesses in your system is a danger for your business. So it's going to exceed the cost of actually going and finding them. It's a bit the same principle with testing, basically, but brought to production. It's very costly if you find something, if your user basically run into an issue in production. Not just in hard money, but the trust they get into your system is lessened. And you don't want that, because it's a cost difficult to actually gauge, but it's going to be a lasting long effect. So we have pitfalls everywhere. Systems grow in complexity so fast, I guess you know that. And the funny thing is, we seem to build new technologies that create new problems, trying to fix all problems, but actually creating new problems. Disciplines. Chaos engineering is not much different in the sense where it's trying to fix something that may not have existed in the past. So what can, I'm sure you find yourself, in some of those points. We have lots of moving parts, especially if you're on microservices, kind of architecture. Things are moving fast up and down all the time. You've got interdependency between the services, but outside, every day now you're going to use Slack, you're going to use GitHub. Once I wanted to actually do a release, so I pushed my code to GitHub, and Travis was supposed to build, but Travis was down, so I couldn't actually even build and then even deliver anything. So it goes very early. Sometimes it's GitHub that is down. You can't even push. The problem is, what if the push you want to make is the push that matters to your system? So really, you want to know that all those links are weak points in your system. We change it at fast. We change at a fast pace. I guess you know that. Security is a major component now. We can't just leave that to someone somewhere, or trusting just, oh, I'm using TLS, I am a security guru. It goes a bit beyond that, I guess. Stricter regulation. Who's suffering from having to deal with GDPR? I'm sure, a few of you, right? No matter the point of the regulation, it may or may not be a good regulation. It's imposed on you, and you didn't, look for it. Reliance on pieces we don't control, weaknesses, ripple effects, especially even more in distributed computing, like and Kubernetes. And the blaming culture. It's not really a pitfall, but I think it is in some fashion. we point fingers sometimes in some teams. I think we're getting better as an industry over that, but it still happens where we're going to blame the one person that pressed the wrong button, when basically we should ask why that button could be accessed by that person. What was in the system wrong, and what we should fix in the system, not blame that person. So benefits of chaos engineering. Because we become proactive, we increase our confidence in our systems, and we increase our trust in our teams. Now, I make a distinction between confidence and trust. Now, perhaps it's because English is not my natural language, but to me, confidence is something we build by seeing. So you get monitoring that tells you this is happening. All those things, you're probing your system, and you get getting on data and data and data. That's building your confidence that something is happening. Maybe automation is going to build your confidence. Trust is way different. Trust is a belief that you have that is somewhat subjective, that that person is going to do the right thing, or that thing is going to act the way you want. But you really want to have both. It's not because you're using G-Cloud, for example, or AWS or anything. You're confident they're doing the right thing, right? But until you've really experimented, you probably don't trust the system yet. So having both, chaos engineering is going to actually provoke the systems and provoke the teams, and you're going to build better confidence and trust in both of them. So, but why? Because it improves your system availability and safety. Now, safety is important here because your users want to be safe for all kind of way of being safe in their system. Your data, their data, and in self-driving cars, I guess safety is quite a key factor. I guess availability. Sometimes we hear about resiliency. As engineers, we care for resiliency. Your users care for your system to be there. They don't really care how you do it. If you're pressing the button behind the scene, they don't really care. What they care is that the system is there. And that will lead to happy and trusting users, which, as engineers, that's what we are there for. So really, chaos engineering is going to give you a better production, happier, as an engineering team, better knowledge of your system, not just, I've deployed, now I'm turning back to my desk, but how it runs, that's a good thing, and your users are going to be happy about that. So why a CNCF working group? It's a natural encounter, I think. A CNCF, and we've seen that this morning during the keynotes, CNCF has laid solid foundations for community and industry collaboration. Really, when I look at Kubernetes, it's actually impressive what happened. You have all those players coming together and agreeing on one platform. So what that means is you, as a user, you now have confidence that you can use those various players. And it's always the same. You don't have to relearn something. You don't really have to. It's the same community. So all the benefits of learning something is doing, even if you move cloud, you're going to carry that knowledge across. So that's really good. And that's actually the most powerful thing, I think, from the CNCF and from Kubernetes. And chaos engineering is socio-technical discipline. Yeah. No. Well, it could be seen that. Sorry for that. It's a socio-technical discipline where you learn from experimental cooperation. It's interesting, the experimental cooperation here, because you cooperate from different teams. Let's say you have a big organization, you have a service support, you have various kind of teams there. Your support engineers, for example, could create chaos engineering experiments directly from what users experiment in general. And that feedback to your developers, who could actually run that experiment and say, well, that's interesting because we didn't think of that. That's a real production use case. And having that under the CNCF means all the knowledge that we all have in production system, we can start gathering that and maybe discussing how to push the boundaries of the way we test them, if you will. So I think it makes sense to have a working group on CNCF on that. Now, down to earth, what are the goals and non-goals of a working group here? Let's start with non-goals. CNCF is not a standard body. It's not the IETF. We're not going to create an RFC. This is just really a way of federating different inputs and people and get interest in there. So we will not try to bless one project. What that means is one vendor shouldn't be blessed just because that's the biggest vendor, for example. That's not the point of the CNCF or nor of the working group. Now, what are the goals? To federate the industry and the community at large and create educational material. That would be already awesome to have actually, educate those who want to actually explore their system live, either staging or even production. Propose an industry-wide definition that users can make their own. Back to the principle of chaos, the definition they give is right, but is it the right one? It's a good one, but is it the right one? We'll have to decide that as together. Provide a white paper. It seems that most working groups around the field create a white paper. I think that's a good thing because at least that gives you, a good summary of all the discussion and where they led to. And maybe crowd the CNCF landscape even more, if we can. That's probably difficult, seeing how big it is already. Discuss the ethics of doing chaos engineering. Chaos engineering is not about breaking stuff without users knowing about it. At least when I say users, your teammates. So there is an ethical question about how far you go about breaking something or harming your system. I think it's interesting to get there. That's why it's different from some security aspect where they do that in the shadow, if you will, which is interesting in itself. Whereas chaos engineering is very much in the transparent public approach that all the teams should know about. At Netflix, they try not to do, for example, chaos engineering during weekends or out of working hours. It wouldn't be fair. And finally, discuss and potentially come up with an API specification. Now, you might wonder what would an API would look like, and I'm not sure we can come up with one. But what is sure is all the cloud providers, all the system that you're using, they have expertise in there. And if they could expose that expertise as a red button that you could press in an automation somehow to actually stress their system to see how your application is doing, then that would be interesting. So whether or not we can come with an API, I don't know, but that sort of discussion is powerful. Next steps, listen to the CNCF community. That's probably a good first step, listen to people. So there is a Slack channel on the CNCF Slack called Chaos Engineering. You've got another, and we'll see the link after that. You have a bigger Slack, which is dedicated to chaos engineering, but both work. We want to propose the working group. Right now, it doesn't exist. We have to go through the process of submitting that to the TOC, and that if they agree, that becomes a real working group, and everything that comes with it. If you want to join the discussion, so obviously you can't click those links right now. But basically, when you get the slides, the first one is we started with just a document where we started to chit-chat. Now, Google Docs is good, but you can't comment at so many people. So it's probably for you to have a read, the discussion that already happened there, and comment if you need, but it's not really the best place right now. It will move on from that. The first meeting should happen like within 1 or 2 weeks. So if you're interested in, it will be on Zoom or something like that. And then, come to the public forums. The first one is a Google Groups forum, so it's mail-based. And the second one is the biggest Slack community that you can find on chaos engineering. And yeah, to finish, really, I think if we come together and we learn from each other, because the funny thing is, when I go and talk about chaos engineering to people, at first they may be meh, but quickly they realize that, yeah, we have production incidents. Oh, that happens. Oh, did I tell you about that? The funny thing is, we have become very good at, as developers, to gather, exchange, see how to do better, like all those things around, development. But as ops, there is a lot of, ground to cover still. And chaos engineering is really an interesting one because it says, don't wait for something to happen, but actually provoke that. So if someone is using a system similar to you and has had the incidents, it's interesting to learn from it, obviously. But then maybe see if you can actually replay that in your system and see how your system would behave. An example that you may have had, I used that yesterday. Let's say your certificates expire. Right? Who has had a certificate that has expired in production? Right, a few of you, right? The question is not it's not really a problem that expires, but it tells me two things as chaos engineering. First of all, did you have an alert for that? That would be a first experiment to actually set a certificate that is bound to expire within the next 5 minutes and see if you get an alert for that. Then you've learned something already. You don't know that it's going to expire. And second of all, really the problem is, what is the impact? What are the ripple effects of that certificates going crazy? From the outside world, browsers are becoming strict about that. And your users won't see the application anymore, probably. From the inside of your application, probably services will start having difficulties to actually even communicate. I'll give you an example I've heard of. A company is using Microsoft and LDAP on Active Directory. All the users were already connected. Most of them keep their session open for a long time. And then someone was hired and couldn't actually log in. They couldn't understand why. And I started to trace all the network and everything. And I realized a few days before that set up a patch on the Active Directory server from Microsoft, but that has changed the TLS, the various schemes you can use on TLS. And suddenly their clients could actually connect because it was using a wrong TLS version. But already connected users didn't see that. So I had a kind of production issue that you want probably to discuss together, and that's why the CNCF is interesting. And then see if we can actually come up with chaos engineering experiments and we can exchange and share together and say, try that, and see if that actually does something to your system. Right, I think that's all for me. Thank you very much for listening. Now, I don't know what time it is and how much I've left. I've got a few minutes to spare for questions. So if you're interested, raise your hand. I'm happy to. And just quickly, on Friday, I've got another session where I'll do some demo about chaos engineering using the Chaos Toolkit. So if you're interested in seeing that, we can come back on Friday morning, if you're still there. Right, anyone? Question? I'll be happy to answer questions more privately if you feel more confident after that, anyway. All right. Well, thank you very much then.